Next, let's talk about palindromes. Palindrome problems can sometimes be efficiently solved with dynamic programming, but they don't usually follow the same pattern of a brute force recursive DFS solution and then memoization and then dynamic programming. They usually don't follow this pattern, but it's still technically dynamic programming. I'll talk about why later on, but I think a lot of people get confused with, does this actually count as dynamic programming? Some people think it doesn't. I would encourage you not to get too caught up in the technicalities and all that. Mainly focus on the concepts. Suppose we're given a string S like this one, for example, and we want to return the length of the longest palindromic substring within S. First of all, let's recall what is a palindromic string in the first place. Well, it's a string that once you reverse it, it's the same backwards. For example, ABA, when you reverse it, ABA, it's the same exact string. Same thing with race car. When you reverse it, the characters read backwards are the same. So another way to, instead of reversing the entire string, another way to determine that would be 2 pointers. If the first and last characters are the same, then we'll look at the next characters, the inner characters. These two are also the same, and then we keep doing that until we finally reach in the middle. And if we do end up reaching in the middle, then we know that the string is a substring, because instead of reversing the entire string, we actually just compared the first half of the string with the second half of the string. If they're equal, then it is a palindrome. That means if we reversed them, they would be the same. So it might be your first instinct to come up with a brute force solution of this problem, and you probably wouldn't think of doing it recursively, because actually there's a better way to do it than, the typical exponential solution that we get when we try like decision trees, because we don't even need to go that far this time. The brute force solution for this problem is actually a big O of n cubed solution. Let me show you what that is. To find the longest palindromic substring, why don't we just take every single substring? So for example, every substring starting at the first character, that would be this substring, that would be this substring, and keep going like that. So basically there are n substrings starting at this character. We can do that for every single character in the input. So, this substring, etc. So there are, in this case, n minus 1, but let's just round it to n substrings starting at this character as well. And we'll do that for every single character in the input. So if we have n characters, how many substrings do we have? Well, we'll have n squared substrings. So if that's how many substrings we have, shouldn't that be the big O time complexity of finding the longest palindromic substring? Not quite, because this is how many substrings we have, but the algorithm that we talked about earlier for determining if each of these substrings is a palindrome or not is going to require that 2-pointer technique we talked about. At least that's the easiest way to do it. So we would start at the end and then work our way inward for every single substring. Now, every substring is going to be of variable length. Like we're going to have, for every substring starting here, one is going to be of length 1, another one is going to be of length 2, of length 3, etc., etc. But we know that the largest one is going to be roughly n. So in terms of big O time complexity, we assume that an arbitrary substring that we look at is going to have length n. Technically, it could have n divided by 2 or 4 or something, but n is a variable in that equation, so that's what we care about. So if this is how many substrings we have, and to find the length of every single substring is n, then the overall time complexity is going to be n cubed to determine the length of the longest palindromic substring. Now, n cubed is not bad, but the question is, can we do better? And the answer is yes. But first, let's analyze how we're solving the problem currently. We're looking for palindromes, but when we start at the character A, we just have a single character. Usually, a single character is pretty much always a palindrome, right? Because if you take a single character and then reverse it, it's the exact same. That's always going to be the case. Now we add a second character here. To check if this is a palindrome, we'll simply compare these two characters if they're equal or not. That's pretty easy. But next, when we add a third character, it starts to get more interesting. Now, we already know whether this substring, these first two characters, whether this makes up a palindrome or not. We already know that. But now, when we try to ask if this substring is a palindrome, we have to start from scratch. Like, this knowing this did not help us at all in determining this entire substring. We still have to do the two-pointer technique and potentially iterate through the entire substring. And then when we add a fourth character, same thing. Whether we know if this or this or this is a palindrome, it doesn't matter. When we get to this substring of 4 characters, we have to start from scratch, do the 2 pointers, and potentially go through the entire substring. Dynamic programming is all about solving sub-problems in an efficient way where we don't have to do repeated work, where the solution of the sub-problem will make it easier to solve a bigger problem. But when we solve this problem in the brute force way, the sub-problem does not help at all in solving the bigger problem, at least not in the order that we are doing it. Because we know with palindromes, if you have a string, you use 2 pointers to determine if it's a palindrome. That's like the intuitive way to do it. So if the outermost characters are equal, in this case they're not, but if they were equal, then what becomes the subproblem? If we want to know if this string is a palindrome or not, and it turns out that the 2 outermost characters are indeed equal, then tell me what becomes the subproblem to figure out if the entire string is equal? Well, simply we ask, is the inner string, not including the outer characters that we already know are equal, is the inner string a palindrome? Because if we know that this is a palindrome and the outermost characters are equal, then we know the entire string is a palindrome. So this is the subproblem essentially. So how does that information help us? Well, first of all, we know that solving subproblems first before solving bigger problems is better. So if we wanted to know if this entire string is a palindrome, we should solve the subproblem first. In this case, this entire string is an odd length string. It has 5 characters. That's an odd number. So we should start in the middle. So the middlemost character. And of course, we know that's always going to be a palindrome. It's a single character. And then we should start expanding outwards. We know to check if a single string is a palindrome, we usually start at the edges and then work our way inward, just because that's more intuitive. But in the context of this problem, if we want to solve the subproblems first, then we should start expanding outward. And that's what we're going to do. So in this case, now we would have pointers at this character and this character. If these 2 are equal, then we're going to continue expanding until we find the longest palindromic substring. In this case, these 2 characters are not equal. A and B are not equal. Okay, so the longest palindromic substring we found was just this character. But that's definitely not the longest palindromic substring. So what did we do wrong? Well, we only expanded from this character. And what that's going to do is it's only going to give us palindromic substrings where this is the middle character. So that would identify this substring for us. It would also identify this substring for us, and it would also identify this substring for us. But what about this substring or this substring or this substring? It definitely would not identify those. So what should we do now? Well, first of all, let's go through every single character in the string S. But instead of expanding it like this, how we did where we just add a character to the right to find a new substring, how about we expand from the middle in both directions? Like we want to find the longest palindromic substring where this is the middle character. Well, that's a pretty simple thing because it doesn't have any characters on the left side. So if we take a 2-pointer approach and we have a left and right pointer at this character and we start expanding outward, we're going to get out of bounds pretty quickly. When you get out of bounds, that's pretty much how you know that we have found the longest palindromic substring. For this character, the longest palindromic substring where this is the middle character is of length 1. And then we can try that with every single character in the string S. So for B, we would start at B and then expand outward. So we would compare these 2 characters. Our left pointer would be here, our right pointer would be here. A and A are equal. So first we had a substring of length 1. Now that these 2 characters are equal, we have a substring of length 3. So then we try expanding outward again. Our left pointer will be out of bounds. Our right pointer would be here. But when you go out of bounds, if either of these goes out of bounds, then we know we can't really expand anymore. So the longest palindromic substring here was 3. That's our longest so far. So we would normally keep track of that. Then do the same thing over here. Start at A. I have a left and right pointer over here. These characters are not equal. So at this point, we don't even need to keep expanding outward because we know for sure if this is not a palindrome, how can it be possible that this is a palindrome? Because if the subproblem isn't even a palindrome, then the larger string cannot possibly be a palindrome. Then we would move to this position, left and right pointers here, same thing. These two characters are not equal, so this cannot be a palindrome. And then same thing over here. We'll have a left pointer here, right pointer's here, it's out of bounds, so we can't really expand anymore there. So the longest palindromic substring we found was of length 3, but hold on, I see one over here that's length 4. So what did we do wrong? There's one last tricky thing that you might forget about. As we were starting at individual characters, we had substrings of length 1, and then we expanded outward. So we essentially added a character to both sides every time. So we increased this substring of length 2 every single time. But if you start with a substring of length 1 and keep adding 2 to it, that total number is always going to be odd. So basically we found the longest palindromic substring of odd length, but that's not what we wanted. We wanted the longest total, whether it's odd or even. So how do we do that? Can we apply the same pattern that I've been talking about, like expanding outwards from a substring? Yes, we can. The easiest way to do it is same thing. For every character in the string, iterate through it. But instead of just starting at a single character, we would have a pointer here, but we would start at this substring. This would be our base substring. So we'd have a left pointer here and a right pointer here. We'd check, are these two equal? Nope. So there's no need to expand outward anymore. And not only that, but this itself was not a palindrome either. So we can't say that 2 is a palindrome. This was not a palindrome. So we would say that the longest palindromic substring, I guess you could say starting here in the middle between these two characters, was of length 0. Then we try that over here. So starting at these two characters, are they equal? Nope. Then we would try it over here. Are these two equal? Yep. So then we would take our left and right pointers, expand them outward. Our left pointer would be here, right pointer here. Are these two characters equal? Yep. So far our longest palindromic substring is of length 4. So we try to expand outward again. Our left pointer would be here, right pointer here. Well, it's out of bounds. So can't really do anything anymore. That was the longest palindromic substring we found so far. Now let's try expanding from these two characters. Well, they're not equal in the first place, so can't do anything there. The result in this case we would return is the length. Remember, that's what we care about. So we would return 4 as the longest palindromic substring. So this can definitely be tricky to come up with, though I think it's not crazy difficult. It's definitely possible to reason about it yourself. But I think it's important to learn this before you start interviews because this can actually be a pretty common pattern that comes up and it doesn't follow the traditional path of most dynamic programming problems. And once you know this sort of trick that I'm talking about, an efficient way to find palindromic substrings, it's a pattern that you can apply to a few different problems. And pretty much once you know the pattern, those problems become a lot easier. So now let's take a look at the code. And by the way, we went through every single character individually first, and then we potentially, for that character, expanded outwards, maybe for the entire length of the string. So going through every single character is n, expanding about that character is n squared, and we technically did it twice, because we did it for an individual character, and then we did it for every adjacent pair of characters. So you could say that the total time complexity of this solution is 2 times n squared, but we know that's definitely more efficient than n cubed. So solving subproblems in an intelligent way can definitely speed up the runtime of our function. Now for the code, given a string s, we initialize the length of the longest palindromic substring as 0. We go through every character in the substring. So 0, 1, 2, 3, 4. We know that we kind of have to take a two-phased approach. We have to find the longest palindromic substring of odd length. So if we were at index 0, we would initialize our left and right pointers at this character, And while these two pointers are in bounds, so while left is greater than or equal to 0, and while the right pointer has not gone, out of bounds in this direction, and while those two characters are equal that the pointers are pointing at, initially it's just one character, so we know that this, of course, is a palindrome. We're going to keep expanding our two pointers. So that's this code over here. But we also want to keep track of the longest that we have found so far. So if we see that the length of our current substring is longer than the longest palindromic substring, then we would reassign this. You could also rewrite this code to call max instead. That would probably condense two lines into a single line, but I don't think that's a huge deal or anything. Now, while we're still at index 0, let's also compute the longest substrings of even length. But we know we have to start with an adjacent pair in that case. So we would basically say that we're at this index. We know our I pointer is at this index. So we would initialize our left pointer here. But we would also initialize our right pointer to left +1, so I +1, so our right pointer would be here, so we'd start at this adjacent pair, and then we would basically run the exact same loop over here. So you can see we have some duplicate code, like these two blocks are duplicates. In my opinion, in a real interview, I don't think this would be a huge deal because it's not a lot of code anyway, but if you want, you definitely can write a helper function that would eliminate this duplication. But overall, that's how things are going to go. We're going to do the same thing at index 1, index 2, index 3. When we get to index 4 and we try to expand for odd length substrings, we know, of course, we're going to go out of bounds pretty much immediately. And then we're going to try the same thing for even length substrings. We're going to have our left pointer here and our right pointer is going to be initialized over here. And then immediately the loop is not going to execute because our right pointer is already out of bounds. So we wouldn't execute that. And at that point, we've gone through every index, and then we can go ahead and return the longest length that we computed. And in case you were interested, this is one way you could rewrite that code to use a helper function. So this is essentially taking that loop, copy and pasting it here, and keeping track of a max length and then returning that max length. We would call that for odd length by just passing in the left and right pointers would be the same initial index. And for even length, the left pointer would be I, the right pointer would be I +1. So pretty much the exact same code. You can see we didn't really save a lot of code anyway. That's why I don't think it's a huge deal to even write a helper function in this case, but it's up to you. Maybe it's something you could ask your interviewer about if they wanted you to do that or not.